In this module, we will continue to learn more about descriptive statistics. Recall that the purpose of descriptive statistics is to summarize and describe the features of a dataset through numerical and graphical measures. These include the shape of a distribution, central tendency, and variability. Descriptive statistics are used to provide insights into the data and help to identify patterns and trends in the data. It also helps in making informed decisions based on the data and aids in the development of models to explain the relationships between variables. Central tendency tells us how to characterize a distribution. We are trying to get at this idea of what a typical is in a data set. We want to look at an average value with central tendency. Most of these indexes you have probably seen before: the mode, the median, and the mean. The mode is the most. It's simply the value with the highest frequency in the data set. The most popular one. So, if you have these ages, the one that has the most frequency is going to be the mode. 27 here. Computer software will calculate this for you. The mode has advantages. It's easy to compute. You just look for the most frequent value and you've got the mode. Mathematicians like this index because it's a real value in the data set and it's easy to understand. It has disadvantages. The mode can be unstable. It ignores a lot of the information in the distribution as it's just the most number. It doesn't really tell us a lot about the distributions. And some distributions don't have a mode because some data points occur at the same frequency, so it can be a little confusing. The median is the score that divides the distribution into two equal halves. The median is popular because it's easy to compute. It's a good index of what's typical because it splits the data in half. It's not influenced by outliers because it's just in the middle. And you can use it with ordinal level data once you rank the dataset. The median also has disadvantages. It doesn't take actual data values into account as it just splits the data in half and it's not necessarily an actual number. The mean is the average, right? You just add up all the numbers and you divide them by n, and you get the mean. This index is one we're going to use a lot in statistics, especially when we start inferential statistics in the next module. The mean has lots of advantages. Actual balance point in the data and doesn't ignore any data points. Therefore, it's the most stable index of central tendency because it incorporates all of the data. The mean has disadvantages. If there are outliers in the data, it will pull the mean in their direction and can give a distortion of what a typical value is. The mean is a computation and is not an actual value. Statisticians have multiple names for the mean. It's listed as m in formulas, and it's also called an x with a bar over it, so we call it x bar. When we describe it as the population mean, we call it mu. The perfect normal distribution has all three indexes of the same value. As the indexes change, the distribution becomes more skewed, and the mean, mode, and median are pulled off center. So, if you have some values that are skewing the data higher, as with a positive skew, it will pull the mean away from the median and the mode. And vice versa, as you get more negative or smaller numbers, it pulls the mean and median down. Another index of central tendency is called variability. This is an index of how spread out or dispersed the data is. Our other indexes cannot convey variability very well. Notice that two distributions can have the same average and yet their distributions can look very different. They can have the same mean, but they can vary a lot. You can have a group of people that weigh about the same, and you can have another distribution that has a wide variability in weight. There are 4 indexes of variability, and each one can easily be calculated by computer software for us. The range of a data set is easy to understand. It's just the range of data going from lowest to highest. The range has advantages when you use it in statistics. It also has its disadvantages. The range is just 2 scores and can fluctuate from sample to sample. The IQR is a little more sophisticated index, right? The interquartile range splits the data into quartiles. So, for the lower quartile, Q1, 25% of the data scores lie below Q1. The upper quartile is Q3. Below that value, 75% of the values lie, or 25% of the values are above Q3. Then the IQR or the interquartile range is where 50% of the scores lie. The IQR or the interquartile range is easily calculated for you by StatCrunch, as we see in this example. The interquartile range has advantages. It's more useful than just the range because it's really looking at the middle half of the data, right? Outliers are reduced in influence, and it can also be used with ordinal measures. The IQR is not without some disadvantages. It needs to be computed by statistical software. It doesn't take all the values into account, and it will ignore some percentages of the data because it's just looking at the range in 50% of the data set. The standard deviation is a little more interesting as a measure of variability. Again, this one is more complex because you're going to have a calculator or computer to figure it out. The standard deviation tells you how much, on average, the scores vary from the mean. So, it's calculated by subtracting the average from each data point. Then you get these deviation scores. Next you have to square them, as this makes all the values positive, right? Then you sum up these squared deviation scores and take the square root of that divided by n-1. It's a much more complex calculation than the other indexes and is often done by computer software. The standard deviation really tells us, on average, how much the scores deviate from the mean. As the standard deviation gets larger, the more things are deviating from the average, or how much variation is in the data set. For a normal distribution, if you look at the graph of the entire data, the data points lie around 3 standard deviations from the average. So, in a normal distribution, 68% of the data lies within 1 standard deviation of the average. A person who scores 1 standard deviation below the mean has a higher score than 16% of the cases, and vice versa for someone 1 standard deviation above the mean. The standard deviation also has its advantages. It is more stable as it takes into account all the data points and provides a comprehensive measure of the variability, allowing for a better understanding of the spread of the data. The standard deviation plays a crucial role in hypothesis testing and determining statistical significance. When values follow a normal distribution, the standard deviation enables comparison between different datasets, as well as with individual scores in a dataset. The standard deviation has disadvantages. Like other indexes, it's influenced by extreme scores or outliers. And, it's not intuitive to calculate. Variance is another measure of variability. It's just the square of the standard deviation. It's not in units of the original data because it's in units squared. It measures the average squared deviation from the mean, giving an indication of how far the data points are spread out. In summary, the choice of central tendency and variability measures depends on the level of measurement of the data. As we go down the level of measurements here, each index can be used. For nominal data, the mode is used for central tendency, while variability measures are not applicable. For ordinal data, the median is often used as the central tendency measure, and the range and the IQR measures of variability can be used. For interval and ratio data, the mean can be used for central tendency, while variability measures like variance and standard deviation are commonly employed to assess the spread and dispersion of the data. We have talked about outliers already in this course as data points that appear as far out values from the norm in our data set. They could be mistakes in recording a measurement, like a typo, or they could represent a true data point that is an extreme value. It's time for a more formal, mathematical definition. Outliers are usually classified in 2 different levels, mild or extreme, based on the percentiles of the data set, or the IQR we just talked about. A mild outlier is a score that is between 1.5 and 3 times the value of the interquartile range below Q1 or above Q3. An extreme outlier is a score that's greater than 3 times the value of the IQR below Q1 and above Q3. So, you have to do a lot of computations to find outliers in a data set. This is almost always done by computer software. StatCrunch calculates all outliers as both mild and extreme. Only SPSS or other more advanced statistical software packages will actually calculate and differentiate between a mild and an extreme outlier. So, for this course, an outlier is a score that is more than 1.5 times the value of the interquartile range below Q1 or above Q3. Let's do an example in StatCrunch of what we've covered so far in this lesson. Let's look back at our ratio level variable example we did to understand making frequency tables, the pertussis outbreak dataset. What is the mean, median, range, variance, and standard deviation here? Once you load the data into StatCrunch, to get the descriptive statistics, you simply click on the Stat tab pull-down menu. From there we chose Summary Stats and Columns. That calls up this dialog box where we can select and analyze the data. We select the rate column here. We just have one variable, so here it's pretty clear. I can select individual descriptive statistics in the statistics area of the dialog box. If I click on them individually, StatCrunch will just do that single one. So, I can click on the N here to start, which would be 33, right? Go back to the Summary Stats dialog box to finish all the stats. Remember, you can just click on the Options button and then edit to get back there if you don't want to start over. You can use the slider bar here in the Statistics area of the dialog box to see all the descriptive statistics StatCrunch can calculate. In the dialog box, one can click on the mean, the standard deviation, the median, the range, or I could click on these Q1 and Q3 to look at the quartiles of the data. Just click Compute and StatCrunch will calculate all of these values. Recall that to adjust the significant figures in the table to display the numbers more clearly, one needs to go to the Edit tab in StatCrunch and select Display Precision from the drop-down menu and change the significant digits to 4. Click Compute and StatCrunch will default to displaying less digits, which is more amenable to displaying the data in a table. Again, you can update any StatCrunch output by clicking on the Options button, select Refresh, and the changes you made will be updated. One can copy and paste StatCrunch outputs easily into Word or other document for assignment reporting. So now we have all the descriptive statistics easily calculated by StatCrunch for this dataset. In the next lesson, we will continue to learn more about descriptive statistics. We will learn about box plots, which reveal outliers very easily in interval and ratio value datasets.